Building an AI application today usually follows a predictable path, a monthly cloud bill that rivals a car payment. This chart shows how those expenses stack up for an application with modest traffic. You're looking at $150 a month in LLM fees alone. Add vector storage, observability tools, and hosting to reach $360 a month before earning a single dollar. But the hardware sitting on your desk has become a viable alternative. Over the past 18 months, open-source models and tools have evolved into a stack that runs entirely on a laptop, bypassing these recurring fees. To build this zero-cost system, you need a terminal interface, an internet connection, a laptop with 16 gigabytes of RAM, and for Windows users, WSL2 enabled. Starting with your own hardware removes the overhead that usually stops a project in its tracks. You can develop, test, and iterate without the pressure of a rising API balance. This is the 8-layer architecture of the zero-cost system. Data flows from user input at the top down to the database at the bottom. We are starting with the foundation, the local inference engine in Layer 3. This component handles the heavy mathematical reasoning. We will use Ollama, a lightweight server that manages model memory and API requests. It handles the configuration for you on macOS, Linux, and Windows. Open your terminal and run the standard curl installation command to get the engine running. Once the script finishes, confirm a defective by typing Ollama-version. If a version number appears, your local server is ready. With this engine installed, your local CPU is now ready to take on the processing tasks usually reserved for remote data centers. For the model, we are using Meta's Llama 3.3 7dB. On benchmarks for reasoning and coding, it performs at a level comparable to GPT-4. However, a 70 billion parameter model requires 140 gigabytes of VRAM to run at full precision, far more than a standard laptop provides. This hardware barrier is solved through a mathematical process called quantization. This diagram shows 4-bit quantization in action. By reducing the precision of the model's numerical weights, it shrinks the footprint from 140 gigabytes down to 12. Crucially, the model retains 95% of its reasoning ability. To download this specific version, type Ollama run llama 3:70b-instruct-q4-k-m into your terminal. The file is approximately 8 gigabytes. Depending on your connection, it may take several minutes, so keep the terminal session active. This breakthrough allows consumer-grade hardware to process billions of parameters, moving the heavy lifting of AI development away from paid cloud providers. Once the download is complete, the terminal becomes an interactive prompt. Type a question or a coding task to see the model in action. The model will stream the response back to you. On most modern laptops, expect roughly 10 to 15 tokens per second. While the terminal is useful for testing, building an actual application requires a way for different software components to talk to the model. To handle this, the engine runs a background server on your local machine at port 11434. This interface is designed to be compatible with standard OpenAI API requests. You can validate it by opening a second terminal and sending a request to localhost:11434 using a curl command or Python. You will see a structured JSON response returned instantly. Because this local endpoint follows the standard API structure, you can point your existing code at your own machine instead of a paid cloud service. Your foundation is set. Your laptop is now processing complex prompts that previously required a subscription to a top-tier LLM provider. The engine is currently using about 12 gigabytes of RAM, leaving enough overhead for the rest of your development environment to function. You have a functional brain for your application, but currently it only exists within the developer terminal. In the next part of this series, we will bridge that gap by connecting this local API to a Next.js web interface deployed on a free hosting tier. By building this core inference engine, you have demonstrated that the most significant cost of an AI application can be reduced to zero.